Hello, in this video we're going to take a look at inductive reasoning. Inductive reasoning is when you make a guess based on patterns you observe. A conjecture is a guess you make based on the inductive reasoning. So let's take a look at a couple of examples. For example, look at the pattern and use inductive reasoning to make a conjecture about the next term in the pattern. So the pattern goes 1, 5, 9, 13, and we're supposed to guess the next term in the pattern. Notice every single time we're increasing by 4. 1 plus 4 is 5, 5 plus 4 is 9, 9 plus 4 is 13. So the next term in the pattern should be 13 plus 4, or 17. Go ahead and try that second one down there, and pausing the video, press play when you're ready to see the answer. You'll notice on that one, 125 to 25 to 5, it looks like you're dividing it by 5 every single time. So the next term in that pattern should be 1 because 5 divided by 5 is 1. The next term we're going to look at is counterexample. A counterexample is when you give an example that shows a conjecture is not true. So, for example, someone notices that a square always has 4 right angles. So the person makes the conjecture that any figure with 4 right angles must be a square. What is a counterexample that shows the conjecture is false? So we're trying to figure out an example that has 4 right angles but is not a square, because that's going to break that person's conjecture, because they're saying, hey, a figure, if it has 4 right angles, it has to be a square. Well, you know what? I can think of a figure that has 4 right angles but isn't a square. A good counterexample would be a rectangle, because a rectangle has 4 right angles but it is not a square. At least not always. Alright, here's one for you to try down below. Go ahead and try it, pressing pause, and press play when you're ready to see the answer. So someone notices that 3, 5, and 7 are all prime. So the person makes the conjecture that all odd numbers are prime. What is a counterexample to that person's conjecture? You could give that person any odd number that is not prime. So for example, we could give the number 9 because 9 is divisible by 3. So 9 would be a good counterexample.